Everyone uses measurements every day. Baking uses measuring cups. When you pump gas into your car, you measure the gas in gallons. We measure how far the cars travel using miles on our odometer. Olympic slalom skiers are timed using a stopwatch. We use measurements every day, but just how good are our measurements? Are they accurate? Are they precise? What's the difference between accuracy and precision? Accuracy refers to how closely a measured value agrees with the correct value. Precision refers to how closely individual measurements agree with each other. For example, a shooter at a gun range shoots 5 bullets. In the first diagram, we see that he is neither precise nor accurate since the bullets are spread out all over the target. In the second target, we see precision but not accuracy. All of the bullets are close together, even though they are not close to the bullseye. The last target shows both accuracy and precision. In the scientific world, both accuracy and precision are important. Accuracy is shown by looking at the methods used and if the measurements were made carefully. But how do we tell precision? We use significant figures to show precision in a measurement. The more significant figures we have in a number, the more precise the measurement is. But what does the phrase significant figures mean? The word significant does not mean important. Important is if a number is necessary. Therefore, all digits are important. Significant, on the other hand, shows precision. If a digit is significant, it means that that digit shows precision in the measurement. So once again, the more significant figures, the more precise the measurement that was made. It is important to note that just using more significant figures in our reports and our calculations does not make the measurement more precise. We can use the significant figures to show how precise the measurement was, but we can't work backwards. So what makes a digit in a number significant or not? There are 5 easy rules to determine if a digit is significant. Rule number 1, the numbers 1 through 9 are always significant. So that just leaves the number 0 that is sometimes significant and sometimes not. The rest of the rules deal with zeros and when they are significant. For the sake of our conversation, anytime I use the word number from now on, that means the numbers 1 through 9. Rule number 2 states, if a 0 is sandwiched between 2 numbers, it is significant. For example, 101 has 3 significant figures, both of the 1s and the 0, which is between the 1s. 70,002 has 5 significant figures. All of the zeros in between the 2 numbers are significant. Rule 3. If there is a decimal explicitly expressed, then all zeros after the numbers are significant. For example, 10.00 has 4 significant figures. The 1, which is always significant, and all the zeros after the number, since there is a decimal explicitly stated. 101.0 has 4 significant figures, since the first 0 is sandwiched, and the last 0 is significant since there's a decimal stated. Rule number 4. Zeros after the last number are not significant if there isn't a decimal explicitly stated. The number 100 has only one significant figure, the number 1. Since there isn't a decimal, the zeros after the 1 are not significant. Remember, that doesn't mean they're not important. We can't get rid of them, because if we did, 100 would become just 1. And clearly 100 is not the same thing as 1. They are important, the zeros, so we leave them, but they don't show precision. Another example, 30,400 has 3 significant figures. The 0 between the 3 and 4 is significant since it is sandwiched, but the zeros after the 4 are not significant since there's not a decimal explicitly stated. The last rule states that zeros before the first number are never significant. Not if there's a decimal, not if there's not a decimal. It's not significant during the summer, it's not significant during the winter, not with a fox, not on a box. Zeros are never significant if they come before the first number. So that means the number 0.000567 has 3 significant figures, the 5, 6, and 7. All the zeros before the 5 are not significant. Another example, 0.05090 has 4 significant figures. The 5 and the 9 are significant. The 0 in between the 5 and 9 is significant because it's sandwiched, and the last 0 is significant since it's after the number and a decimal is explicitly stated. If you would like to practice to see if you can identify significant figures, push pause while looking at these numbers. The answers will appear in about 5 seconds.